An introduction on paper 2 and how to prepare for this exam, because there are some type of questions that come up every year and that they're very important to analyze, okay? And those are the ones that I'm referring are practical skills, okay? So there are practicals, not that many in organic chemistry, but they do come up and give you a lot of marks. Okay, and so you have a list, of course, of all of the topics that you have, and here I'm going to skip through. Okay, the practicals that I'm thinking about. For all of the exam boards, you're going to have the synthesis of organic solids and liquids, okay? Like also the organic test, but yeah, the main one, preparation of organic solids and liquids for a QA, and synthesis of organic liquids and solids for the OCR, okay? Qualitative analysis and organic tests, it's actually the same, but here is just about the chemical tests that hopefully you study in every functional group, so then you should be able to just put it all together. But then, yeah, I would say the most important one is really the synthesis, okay? Because with the question, they're always quite open, and you need to normally design an experiment. And one interesting thing that comes up with these type of questions, like with the synthesis, is actually calculations. Okay, so a lot of calculations of like a percentage yield. Yeah, mostly percentage yield, it's included in it. Okay, that's why you have so open question. As usual, to revise the practical, remember to have a look at the topic, what it's talking about. And for example, in organic synthesis and solid, it's useful if you notice which functional group are you actually synthesizing. That's so that you understand also the different tests. Okay. Then you can analyze, of course, as usual, the variables, the dependent, independent control variable. If there is any data manipulation in the case of organic synthesis, not really, but you can still think about the like how you like the calculation that you do and the percentage yield, you know. A limitation of the instruments, well, as always, you needed to describe everything in practical steps so that another person could follow. So make sure you mention all of the glassware that you use and the actual steps, because with these organic chemistry practicals, you often have like the recrystallization or in general, the purification steps that are very important and definitely give you many marks, okay? So make sure you revise all of the instruments. Also for the separation method for organic liquids, you have the separating funnel, so it has quite specific shape and way to use it. So it's worth revise it in a more details, and maybe you remember it also from what you've done at school. Okay. Also, distillation, it's an important one. Here it's related to like the practical for alcohols, and alcohols is still an important topic that can come up because it links, of course, to aldehydes, ketones, and carboxylic acid. Okay. So some important things to consider. Many topics can link with this one also, for example, the boiling point, like explain why if you want to make an aldehyde, you use distillation, why is reflux used, okay? And also they can give you these little suggest questions where you're like, okay, why do you use anti-bumping granules? How do you seal the condenser and the round bottom flask? This one, is it sealed or open? Okay, all of these little things. Anti-bumping granules, remember, it's used to prevent the splashing and the formation of large bubbles, okay, so that it mixes all evenly. And under reflux, we want, like, it's just prolonged heating for substances that normally, well, we're talking about organic molecules, meaning that these will be flammable, so we don't want open flames, okay, and also prolonged heating, okay, so in the sense that, for example, if you want to make from primary to carboxylic acid, it's two oxidation reactions. If you had something open or distillation, you will get an aldehyde because lower boiling point, as soon as it's formed, it's released. Okay, so that's the type of considerations to do. Organic tasks, qualitative analysis, I would just like you to try some questions and look at the notes. One tricky one that actually I want to highlight because I've seen some questions coming up and they're not that straightforward. Is these tests. Let me highlight it with a spotlight. This test, okay, for the rate of hydrolysis of haloalkanes. Okay, this is one that tends to be forgotten, but the test, you know it because it's a silver nitrate, and we know that silver forms a precipitate of different color with chlorine, bromine, and iodine. Okay, but we're talking about the investigation of the rate of hydrolysis of haloalkane, meaning that you need to react the haloalkanes with a nucleophile, which is the sodium hydroxide, and this is what then it will release the halide. Basically, it's just a substitute, a nucleophilic substitution. So you could have some nice links here for the like mechanisms as well. And then remembering that is a precipitation reaction. Okay, so yeah, I think that's okay. And yeah, and basically how long it takes to form the precipitate. Yeah, we can discuss the rate of hydrolysis. And also here links to bonding topic, because you may need to explain, okay, why is silver iodide formed faster than silver chloride? And here it's remembering the mechanism, which I think it's worth to do it, just because I like to link all the topics. So for the and this could be some really nice suggest questions like that. So if we have just any haloalkane, I'm going to take this X is our haloalkane, okay? And we have OH is our nucleophile, okay? Delta positive, delta negative. Remember that it's one-step mechanism, but in the rate determining step, which is of course the first one, actually, we have the breaking of the carbon halide bond. And that's what determines then the rate of reaction. Okay, because the stronger the bond, the lowest it would be. In fact, as we know, as we go down the group, so chloride to iodide, because iodide is a much larger ion, the covalent bond, larger atom, the covalent bond, it's weaker, easier to break, faster hydrolysis. Okay, because guys, we cannot forget the basics of bonding and all of the foundations of physical chemistry, because they do really come up, yeah, in this type of question. Maybe just a few little marks, but still, just be aware of the connections that we can make. Okay, and rate of reaction, that's exactly what I said. So if you want to revisit these notes, please feel free to go in the classroom and do that. Preparation of organic liquids. I want you to focus on the apparatus really, and then you can look at these steps in your own time for revision, because there are some key things that are done in this. And so if you remember, and also again here, can link again to the bonding and the intermolecular forces, because if we have different density liquids, why do we have different density? Well, because we're making an organic molecule. Often this is used for like making esters. Esters, they're not soluble in water. Okay, so they're not soluble in water. We are able to separate them, or they would form a different layer if we mix this mixture with water. Okay. And as you can see, we have this stopcock, and basically we just need to separate the different layers. Okay. Of course, there are some other steps here that it's worth to mention, that like how to use this instrument that you're shaking it and you want to release from pressure. The pressure normally comes from the carbon dioxide that you add, like, for example, you add a sodium hydrogen carbonate, because you're kind of like removing the other substances, but therefore some pressure it's formed, you know, so you have to release that. And then if the layers separate, you separate the two different layers, and then you must use a drying agent, because it's possible that a little bit of the two liquids mix. Okay. And then, of course, the purification is distillation. So you distill and collect the pure product. So this is a step that sometimes it's not easy, because you may think, okay, so if you've done the drying agent, then it's already pure. Not necessarily. So you always need the distillation. And this is the organic liquid. And we have this type of reactions actually. So this is possible, and these are some reactions. Let's analyze a little bit these reactions just for revision of organic chemistry. Take a moment, maybe pause the video and discuss what are these reactions, if you can recognize the type of mechanism. So I hope you had some time to look at these reactions. If you want extra practice, you can also do the mechanisms if you need to know them. Okay, that's always a chance to revise the mechanisms. So let's look at these three reactions. So the first one, we have a substitution because the chlorine has taken the place of the OH, specifically nucleophilic substitution. Okay, nucleophilic substitution. Second one. I know this is a reagent that is always a bit tricky to remember because it's not that it's like straightforward, but at AQA you do need to know this mechanism, so please revise it. And this is elimination. Okay, because of course we have removed the OH. And the last one, it's a condensation. Remember, condensation always uses the acid catalyst, normally sulfuric acid, okay? And of course, it releases water. For condensation, you don't really need to know the mechanism, but you do know it because it's the addition-elimination mechanism, okay? And you've seen that in like amines, amides, okay? So similar to, because of course, carboxylic acid derivative reactions. Okay, so also notice that the product that is formed has water as one product and the organic molecule. This organic molecule is the one that is not soluble, so will have to be separated. Okay, good. For preparation of organic solid. Now, the most important part of this, apart that you like just mixing things, so as usual, like same, common sense on describing steps of a required practical, but the one worth revising is the recrystallization. Okay, so here you have the step and the reason. I would suggest you to pause the video and read through it just because I've seen some questions before that they really ask you, why do you do this? Why do you do that? Why do you cool it? Why do you suction filtrate? You know, all of like that they ask you to explain the steps of each like they ask the reason of each step. Okay, so please take a moment to read the reasons. Very nice is also the like the relative question of like why like explaining the yield of the product, like the loss of yield. Okay, and so here are some steps like the crystals are lost, the products stay in the solution after recrystallization, sad reactions occurring. Okay, this could be a nice question that can come up. And of course, as I said before, amount of substance is tested across the whole paper, so yield it's tested in this type of questions. Okay. And organic solid, normally the test is the aspirin. Okay. And let's look at this example for a moment. Okay. We have ethanol anhydride and salicylic acid is used instead of acid chloride. Okay. Because as we know, as you have seen this reaction before, at the end is just a condensation esterification. Okay. I hope you can notice what changes in the functional groups. Let me highlight it here. Notice that this alcohol now has become an ester. Okay. Of course, this can be done with carboxylic acid, acyl chloride, and acid anhydride. Okay. Acid anhydride is used because it's cheaper, it's less corrosive, less vulnerable to hydrolysis, and less dangerous to use. Okay. Because otherwise, if we use hydrochloric acid, chlorine will be the waste product. So this is really the reason why this is used. And also it's more reactive than carboxylic acid. That's why carboxylic acid, they're not used. Like it's actually ethanoic anhydride, like acid anhydride and the acyl chloride that used in preference to carboxylic acid for like esterifications or condensations. Okay, so yes, sometimes you also have not just describing the required practical, but also something related to the functional groups and specific to this type of reaction. Okay, and what else? So the other type of solid that you might have is this one. Let's take a moment to think about which reaction this is. So this is benzene and benzene that gets substituted with an O2. So it's called nitration of benzene. And to remember, very important, in benzene reactions, you need to remember how the electrophile is formed. Okay, we have nitric acid and sulfuric acid. And we have a very nice reaction taking place. So you can expect a random acid and base question here. and we have this reaction taking place. I know we're talking about practicals, but I do like to mix it up. Okay, so we have two acids, but one is stronger and one is weaker. This is what happens. HSO4 minus and H2NO3 plus. H2NO3 plus dissociate into our electrophile, NO2 plus, and water. Can you guess which of these is acting as an acid and a base? And if you want to provide a bit of acid and base, can you write the conjugate acid and base product? HNO3 is gaining a proton, meaning that it's our base. H2SO4, proton donor, is going to be our acid. HSO4 minus it comes from H2SO4, of course, so it will be system number 2, but it's going to act as a base on the backward reaction. H2NO3, of course, is going to be our acid one. Remember, little questions of all of the physical chemistry can still come up, okay? And yeah, anyway, let's take a step back and talk about just organic chemistry. Did you recognize the type of mechanism? We have substitution, but it's benzene, so it's electrophilic substitution. Okay, electrophilic substitution. Now, because we are talking about benzene, I want you to notice that NO2 is added over here. It's not added in any other position. Okay, this gives us, this makes us think about what type of directing group is this. Okay, just to have a very, very brief revision of further substitutions of benzene. Remember that if we have a group that is an electron donating group, so it increases the electron density of the ring, makes it a stronger nucleophile, more reactive, it would substitute at position 2, 4, and 6. While if it's an electron withdrawing group, it takes electron density away from the ring, decreases their activity, okay, because it makes this ring less available. Substitute at these 2 positions. To identify the substituents, okay, if they have a lone pair of electrons, for example, if this X was an NH2, it has a lone pair of electrons that can be given to the ring. OH also can give to the ring. But when it has a double bond, you know from all of the mechanisms that you've studied that the electrons are taken up to the carbonyl. Oxygen is able to do that to form an intermediate that looks like this, but these electrons, they have been taken away from the ring because it would be the consequent movement. So whenever there is a double bond O, we have an electron withdrawing group. In fact, you see this one, electron withdrawing group, because it's substitute at position 3 or position 5, which will be exactly the same. Okay. Closing the bracket of the mini revision for benzene, where we will go into more details, but focusing on the practical here. So when you have a required practical and they ask you, for example, why it's in ice or to recognize the conditions, you always need to think if the reaction is endothermic or exothermic. If ice is used, it's very likely that it's a exothermic reaction. So if it's exothermic, the acid, it has to be kept cool and also added dropwise, because otherwise it would cause multiple substitutions. Okay, so this is really the reason why the rate sometimes has to be kept low if it's an exothermic reaction. So this could be a very nice suggested question in a required practical. Okay. Purity of solids. Now, we've seen that we've seen a distillation for liquids, recrystallization for organic solids. How do we determine the purity? Well, we look at the melting point using the melting point machine, okay, or you might need to describe how it works, but it's a very simple instrument to use. You have a sample in the capillary tube, and then it's heated up slowly near the melting point. And then whenever you see you actually can visualize and observe the crystals melting. And now, if impurities are present, the melting point will be lowered and the sample will melt over a range of degrees. Okay, so also, if you needed to find the purity of a substance, you can just compare it with the tables, and like this, you would identify the melting point. Or yeah, if you see that it's melting over a range, it means impurity, that is impure. Okay. So TLC, I'm not going to cover it here because I think it's something that you just need to revise maybe a little bit because it's not that difficult, but it is linked to the proteins topic and sorry, the amino acids topic. Very important. Actually, the only point I want to make with the thin layer chromatography, you've described a million times how to prepare, this TLC plate with the pencil line to calculate the RF value. Okay, so I'm not going to cover that. But the important thing here is that to see how much amino acids have moved, you use a UV lamp, okay? Because the spots otherwise will be colorless, they're colorless and not visible. And like this, you can observe like the amino acids. Otherwise, you can use lanhydrine. If you spray it, the amino acids become purple. So you can actually see how long they've traveled, and therefore you can calculate the distance move, and therefore the RF value to determine the amino acids. Okay, I haven't seen many questions coming up on this, but still, it's worth mentioning it for extra marks. Okay, organic synthesis, organic analysis. We're going to go through many questions of this because it is really the most difficult part. In organic analysis, we need to get used to combined techniques. You will have a nice summary of what each technique is used, okay? Because, yeah, we can't get confused between them because each technique gives us different information. Mass spectrum, the MR, infrared, the functional group, NMR, protein and carbon, the actual structure. So let's go into some practice or exam questions of organic synthesis. So I would say organic synthesis and organic analysis.